Well, thank you and welcome everybody. This is Florence Hudson. I'm Executive Director of the Northeast Big Data Innovation Hub headquartered at Columbia University. And this is the, believe it or not, June 2023 Data Sharing and Cyber Infrastructure Working Group call. And this is sponsored by all the 4 Big Data Innovation Hubs. So I always want to thank Chris for managing us. Thank you, Chris, for keeping all the communications going and setting this up for us. And so today we're super excited to hear from a few speakers regarding the role of natural language processing in cybersecurity operations. And so I think what I'd like to do is pass it off to Jay Yang. Professor Yang is at the Rochester Institute of Technology, and he has a number of folks presenting with him, Steve Moskal, Reza, Fayazzi, and Pradumna, Gautam. Jay, take it away.
Thank you, Florence, and thank you, Chris, again for hosting this. This is Jay. I'm a faculty member at RIT. I'm a professor in computer engineering, also director of global outreach for Global Cybersecurity Institute. So I have a couple current students and one former students will be presenting today. I wouldn't take credit from them. It's their work, their research. I will just do a very quick opening and then hand the floor to them. So as most people on this floor, maybe future people watching the video online knows that the ChatGPT or large language models in general has gotten a lot of attention in the recent months. And particular, maybe from our perspective, is how it affects the cybersecurity kind of problems, the research problems and actual operational problems. So my students and former students have been looking into this. Well, actually, before I think Steve, before he graduated, we started looking into the use of LLMs, but not GPT. At the time, GPT was not released. So since then, that he has done a lot of interesting things. I look forward to hearing from him that what he has done. So I look forward to hearing from Steve, also from my current student Reza and the visiting student Pradumna as well. So I would suggest that Steve, Reza, and Pradumna, why don't you briefly introduce yourself, and then we'll hand the floor to Steve to start presentation.
Yeah, sure. Thank you. So I'm Steve Moskal. I am Dr. J's old PhD student, and now I have moved on to being a postdoc here at MIT for the NEScale for Learning for All lab here in CSAIL. So.
Okay, hello everyone. My name is Reza Fayazzi, and I'm a first-year PhD student at Rochester Institute of Technology, working with Professor Yang. And a quick intro to my research. What I've been trying to do is to leverage NLP and large language models in particular to process cyber attack descriptions and get the intended consequences of those descriptions to see what adversaries are trying to accomplish. And thank you.
Hi everyone, this is Pradumna, and I'm a visiting research student with Professor Yang, and I spent my last spring with Professor Yang researching in NLP and basically natural code intelligence, and I've been trying to deal with how we can use the neural code intelligence in the field of cybersecurity as well. And I'm done with my undergrad, and I'm upcoming grad student at UCLA. Hopefully I'll present my topic very good. Thanks.
Thank you, Steve. Why don't you take it away? I think Chris, we can share screen, right? Yeah, go ahead.
Yes, you should be able to. Perfect.
Great, cool. I see. Hold on one second. There you go. Cool. So thank you for inviting me today, Dr. Yang and everyone else here. Again, I'm Steve Moskal. I am in the NEScale Learning for All group here in Alpha. My PI is Uname O'Reilly. And today I'm going to be introducing the concept that I've been developing called zero effort cyber agents. And this is going to be automating the cyber attack campaign using a large language model, which is going to be ChatGPT or the API version 3.5 Turbo. So I think where we can start first is the idea of the cyber arms race. And so, here is just kind of like an abstracted idea of, the types of attackers that are available and their skill levels in relation to like the system defense or the complexity of the defense available. So like prior to LLMs, we have the idea of a script kiddie who uses pre-made scripts and throws them against some sort of network in the hopes of, you know, going through and getting some sort of access or something like that. And those are low skill level. You don't need to have a lot of knowledge within. And then we start to scale up towards the kind of, you know, specialized mercenary red teamer who, you know, has a lot of knowledge, maybe have the ability to build out custom tools, et cetera, all the way up to a state actor where you need the most sophisticated firewalls and SOC to defend against them, make sure that you're going through here. But today I'm going to be introducing the idea of zero effort. And zero effort is using a large language model to help you throughout the attack campaign and not have to do any work for yourself. And this is the concept of bringing or raising the skill floor to perform a cyber attack. So we have the idea is that now with the introduction of large language models, you know, a normal person who does not have a huge amount of skill can now exceed the capabilities of, say, a script kiddie. And then we also have the concept of the doomsday scenario of what happens when an LLM raises above the skill level of like a state actor. But that's in the future. Today, I'm going to show you kind of a brief idea or a brief demo and scenario of where we can automate an entire attack campaign using just the knowledge within a large language model. So in 2023, early 2023, ChatGPT blew up. And so everyone decided, let's see what the knowledge is. It's very cool. It can generate text. It can reason, tell stories. But, you know, I'm going to start with just kind of this toy example, this realization of just the general capabilities of the large language model that immediately got us to start thinking, well, how do we leverage this farther? How can we push this even farther? So no need to really read you know, what's going on here. The idea is that I instruct the language model that you're helping me plan actions for a red team cyber attack campaign. We have to infiltrate the network, and I use some sort of prompt engineering or prompt delimiters in this case to kind of start framing out the different contexts needed that can provide, you know, that can give us a meaningful result out of this language model. So basically the big ask here is that I don't know anything about my network, but I know that there's a MySQL server containing sensitive information. And then I instruct the model saying, I'll give you more context as I find it, but guide me through this process. So I asked it, what should my first action be? And our first action is, well, conduct recon. And you know, you got to identify targets, and we have to do network service scanning. That's pretty cool. And it even recommended Nmap. So this is just like a one little toy example of when we're starting to see, oh, okay, there is some capability here. So the next thing that we decided to do is, well, what if we try to like automate myself, you know, going through this process of here's the knowledge that I have, what should I do next? And then once I find out what I do next, I execute that. And then I, you know, try this again and have the language model guide me through this process, which then comes to this idea of an LLM accelerated cyber agent. So we imagine we can have two sides of the game here. So we have the left red team side, which is you are a penetration tester. Your objective is to do this. This is what I see. And we use the LLM as a brain, you know, as a knowledge corpus to then start feeding me actions. Maybe I'm not a skilled attacker. I don't know anything about cybersecurity or just a little bit. Can we get this to go through our process? So our overall system framework is, or our whole idea of zero effort is to model both the red and the blue and see what happens when we can model or play the game against each other and have the LLM AIs start to send actions over from the red team and then let the blue team observe those red team actions and then have the LLM go through here. But I should mention today, we are only going to be talking about the red team side. So the idea is can we get the LLM to feed us executable actions that we can then start gaining more and more access into the network. So this gets into the concept of cyber planning. So the major idea here is the cyber attack kill chain. That is the kind of the most intuitive way to understand how do we plan a cyber attack. So you might start off with just, okay, first I need to do reconnaissance. What are the preconditions and the post conditions that I need for reconnaissance? Well, if I know nothing, then I should do reconnaissance. And those are tactics. And within there is we have action spaces to perform those tactics. And so those could be exploits, Metasploit modules, Nmap commands, command line. This is where the automating cyber attacks goes, complexity goes through the roof, is because now we have to consider, how do we run exploits? How do we run Metasploit commands? When we run recon, we have to understand what that recon scan is even doing or even saying, what vulnerability or what services are open. And then we have to then take that information and then figure out how to use it. And all of this really makes automating, I would say before, prior to 2023, really difficult. We would have to understand, okay, we get an Nmap scan and we have to parse it. And then we have to get the meaningful information out of there to then select an action. And this becomes really, really difficult. But because the way these large language models now work and they're trained on massive amounts of data, trillions of tokens of data, and it learns all this general knowledge that is contained within our language structure. We now, the question was as well, how much cybersecurity knowledge is embedded into one of these models, and whether or not we can consistently elicit the information out of these models so that we can get consistent agent behaviors. And so this kind of got me thinking of, okay, what would be the components of a cyber LLM agent? And so right there is we have the action space. So we have to be able to have prompts to instruct the model to output executable commands. Like I said, with Nmap, we have to understand what the response of an Nmap scan is even telling us, the user, and then how do we get that information out to the LLM for it to reason upon. And so we have the phase where we want to have response understanding, translate this gross Nmap scan that's highly specialized, has keyword services that we know a novice person might not have any knowledge of. They would have to Google it, they would have to reason upon, well, how do I use this? Let's let the LLM do it. And then third, we have to have some sort of knowledge of the cyber attack kill chain, the phases of attack. We can't just immediately go from, I know nothing, give me the exploitable code. No, first we have to do some sort of reconnaissance, be able to track the knowledge that we have, build out context, because again, we know nothing about the network. Let's just assume we know nothing about the network. Well, we have to build up that knowledge base, and we have to instruct this knowledgeless, or like LLMs have no memory. So we have to build out this knowledge base for the LLM, so then it can reason upon an environment that we know that it knows nothing about. But as we're finding out, the LLM can understand this kind of context of, if given enough context about the network, it can start reasoning upon environments that is brand new to it. Yes, it was trained a while ago, but it can, if given enough new information through prompting, we can get it to reason upon that. And then grayed out here is not part of this work, but is what happens if we have multiple targets. You know, say we're on, you know, a subnet and we see 10 different targets. Which one do we focus on? That's for another time. So this comes out to the concept of plan, actor, reporting. And this is the collaborating with language models for embodied reasoning paper from DeepMind. This is definitely a paper that most people, or if you're working with LLMs, definitely look into this. This is kind of like a flagship paper of how do we get it to first observe a network or observe an environment. In this case, it was robotics. But how do we observe its environment, give actions, and then try to understand this? So I took this information or took this concept and then applied it to the cybersecurity domain. So first on the left here, I have a user-provided initial prompt, and this will give us the goals, the current state of the attack or of the campaign, and which then feeds into our first block called the tactic selector. And this will, given what we already seen or what we know, select a kill chain stage that is appropriate for this model or for this scenario. So for example, if we start with nothing, then it will move into and say your tactic is network service discovery. We need to do some recon, which goes into our execution stage. And I should mention, each of these uses a different prompt. Like the tactic selector has a different prompt from the execution stage, has a different prompt from the output translation, where I compile all this information to build out the next, to build out the state of the LLM. And this all just uses one LLM, and there's no fine tuning, it's all just prompting and then giving it the correct context to make it reason upon this environment. So once we have selected a tactic, we have a separate prompt, which I will not be giving all my prompts today as an interest of time, but I will be going over my execution stage next. But this is where it gives out our executable, such as Nmap, which then we execute on a real environment in Docker. And that gives us the output of the Nmap, which again, the output of Nmap can be, it's relatively unstructured. It can have many different services. It can have just a bunch of garbage text at the bottom. And then we just feed this into the LLM, say, you are translating this, give me useful information, which, compile all the services together and tell me whether or not you thought this action was successful or not. And so this will first test the understanding whether or not the model even understands the output that it received, and then it decides whether or not we should proceed or that was useful or not, that leads towards our campaign. And then this goes back into the loop, and then we keep applying this process over and over again to lead us towards our goal, which is exfiltration of a web server on a machine. So let's just go. This is going to be a pretty big slide, or I'll talk you through it, but this is going to be the kind of prompt breakdown of our execution stage. So our task on the left here is commands, or our task is to give me an executable set of commands to given some sort of context. So our prompt outline, which lines up with the orange boxes here, is first we define some sort of task. The task is to gather information, exploit, and exfiltrate data from the network. This is framing our goal. This is the setup prompt or the system prompt in GPT Turbo. And then we also give its capabilities of the user. So in this case, we have a Kali Linux box that has Metasploit in it. This immediately frames our model to only consider actions that are available within Kali Linux or Metasploit. And then I start giving it some environment details, some sort of context of what we're even doing. Currently, we have identified a target at machine IP address 172. And then I give it our history. Our last action is that we run nmap SV1. That will have all of the service information from the scan, all that. And then I give it that entire nmap scan unformatted. I just give it the whole thing. And then what really works out super well is now you can use the LLM to format your output in a very specific format. And you use this aggressively in terms of commands. You really got to tell this thing, do not give me extra text. Say this when we're done generating commands, and only output certain types of commands here. And so right here at the top of the screen, you can see this prompt given some nmap scan, the actual nmap scan will output use exploit VSFPD 234, set the R host with the IP address that we have defined and the correct port, and then run this. So now the question is, well, can we run this? Is this valid? Is this something that we can actually do? So I created a kind of network environment sandbox that contains the red box of the Kali, targeting the blue box, which is a Docker container called Metasploitable. And so it's a really easy box to pop a root shell. I mean, it's called Metasploitable. But the idea is does the LLM even understand Metasploit? Does it, is it able to craft the commands correctly? That's what we want to test. But also throughout this, we want to be able to sense what is happening on the blue team side. So eventually we can then have on the other end a zero effort defender controller. And then we can see, or we can hook it into Splunk, start reading commands or start reading alerts, and then start making actions on here. But either way, we're just going to be using ChatGPT 3.5 Turbo. And I'm going to step through a example scenario where I go through three stages of the kill chain using one given prompt. So this might be a little small, but luckily we're on Zoom. So the prompt that I give this at the very beginning of this setup is, the task is to gather information, exploit and exfiltrate data from a machine on a network. We are at the beginning of the campaign where no vulnerabilities or services are known about the target. The known IP address is 172.16.2.3. What actions should I conduct? So again, no knowledge is understand, but we're going to be going through my tactic selection, execution stage, and then translation stage prompt chain. I should mention multiple are performing multiple API calls to the LLM and then compiling all that. That's called a prompt chain. And so the prompt chain is a very good way of kind of giving iterative, consistent results from the LLM, compile all that information, and then finally get the exact text you want here at the end. So first, I send this prompt to ChatGPT. The tactic selector will first say, this is recon. I have it restricted to only tell me if I should be in recon, exploitation, or exfiltration. And so this is a very simple prompt call that says, given my prompt or given my context, what kill chain stage I should be in. So we get recon. And then we use that information, and then we also craft the prompt in the execution stage specifically to say that we are now in the recon stage. We give the execution stage prompt that you saw prior this notion of what attack stage we're in. So just on this prompt alone, it then gives us nmap SV, which is the kind of loud, but gives us the service information. Then we execute that action on our Docker environment, and then we take that execution from the terminal that gives us the MNAP, and we feed that back into the output translation stage. And so the output translation stage has two tasks: summarize the output given from the Docker container, and then also reason upon whether or not it's successful, or the execution of that action was successful or not. So first we can see that right at the beginning, it says success. Yes, this was a successful Nmap scan. It has recognized that we are on the correct IP address, and then it starts to summarize port 21 VSFPD, gives a very nice and concise summarization of the Nmap scan. So you can see at the bottom here, based on this output, the next action should be focused on exploring vulnerabilities for identified services and versions to gain further access to the target machine. So let's do that. But we let the LLM handle that. So at this point, hands are off. I'm not touching anything. I'm not doing anything. The model is now going to be kind of reasoning on its own. So given this Nmap scan, it is determined that we are ready to exploit. It has enough information and I bolded VSFPD in the recon scan. And now you can start seeing, okay, it gives use, exploit, whatever. This is the direct command that you would put on Metasploit, and it's configured correctly. It sets the payload, and then you hit exploit. Feed that into the execution thing, or the execution environment, and then we get the output translation. Success. The penetration tester targeted the machine using VSFPD backdoor and successfully gained root access to the machine. The output shows that a command shell session was opened and the UID is root. Very cool. So it is recognized that we have a root shell, and now we should investigate, well, what is it going to do next? And here it's exfiltration. Now this is where the design kind of goes a little haywire. I would say that the first two stages, recon and exploit, very consistent. I can change the services available. I can make the box a little bit harder to reason upon. Yes, Dr. J.
Yeah, so I don't want to interrupt you. I do want to leave the audience some time for interactions and Reza and a little bit time to talk about their things. Just want to remind you about the time.
Yeah, okay. Yeah, I'm almost done here, actually. So not a big, so I'll be done. So anyways, exfiltration generally requires a little more understanding of the actual machine and the root shell. But in this case, what is determined is to just take all the password files, everything from the machine, zip it up and exfiltrate it out using a netcat command. And then it also finds this successful, which then ends the campaign. And this archive contains various system files, password files, shadow files, whatever. So I won't spend too much time on this, but there are many different vulnerabilities on this box. It ends up, out of the ones that are possible, it ends up getting 6 out of 9 of them. Pretty good. But again, very easy, remotely accessible machine. So again, nothing a script kiddie couldn't do, nothing somebody with some advanced Googling can do or can't do, but I only put one prompt in, so that's pretty cool. So in conclusion, I would say GPT 3.5 understands Metasploit. It has situational awareness of when to conduct certain types of actions. It can form syntactically and contextually correct executable shell commands. It can interpret whether or not the actions were successful based on the output. And again, no prompt engineering no fine tuning or external context was needed here. It's just really, some prompt engineering, some engineering in the way that we send off prompts. But this whole thing kind of made us pump the brakes a little bit because there are some ethical concerns about this this type of work. Since then, we're able to do a lot more than just this demo. So that's a little concerning, but That's one thing that we're really focusing here and now is, ethical concerns about models or the usage of these models, and then also we have a defense capability of this too. So it was
Great.
really,
Thank you, Steve.
Yeah.
So I think we have some choice. I want to ask Chris and Florence on the timing things. Pradumna and Reza, they probably each have just a few slides, maybe 5 minutes at most. But I also think that would be very worthwhile for audience to ask Steve and Reza and Pradumna some questions. And Reza probably might also have questions. How would you suggest we proceed? Ask questions now or let Reza and Pradumna present?
This was fascinating. And, Steve, I saw somebody showing how they're using ChatGPT to do internal phishing tests. And I was like,
Yeah.
well, that could be used for real externally too, right? So I agree with you that there are a lot of ethical concerns with this. It could be used for good or for bad, which is one of the big challenges, I think, with these large language models. But I think what I'm thinking is that, Jay, maybe we have the other two presenters present, like you said, for like 5 minutes each, and then we do the discussion together. Is that okay?
Sounds good. Reza, please go ahead and please keep your presentation within 5 minutes, and same thing for Pradumna.
Sure, will do. All right, let me share my screen then. All right. So I'll try to keep it short. So I can start now. Again, hello everyone. So what I have been doing for my research is using large language models to interpret ambiguous cyber attack descriptions. So as a little bit of introduction, with the vast amount of vulnerabilities, with their volume and variety of change in them, also it has made incident threat analysis very challenging. And TTPs came around to describe how attackers exploit vulnerabilities. However, a TTP description written by a cybersecurity professional can be interpreted very differently. So what this does is that it leads confusion in cybersecurity operations or even business policy and legal decisions. So what the question that we had is that how well can large language models like ChatGPT can interpret these TTP descriptions? So the aim of our work is to analyze the direct use of large language models like GPT Turbo, and also training based large language models like BERT or SecureBERT, and see how different they perform and how capable they are in predicting the attack tactics. So in terms of using the API of GPT 3.5, we did prompt engineering, and as to just briefly show here, what do we basically ask it? This is the prompt, and what we basically ask it is, we are giving you descriptions from attack framework, and your task is to predict any of these tactics that there is. We also did a few shot learning here. We gave it 2 examples for it to understand how it should perform and predict the tactics. And then we said you can now write the output in the following format based on the descriptions that we are giving you. This was one for the use of the API of large language models, and also for training supervised based large language models like BERT or SecureBERT. What we did is we gave it the descriptions, and then what we did is doing multi-label training with the attack framework and the attack descriptions, and then asking it to predict the tactics. So as for the results, first I'll show here the heat maps. So one thing I should mention is that as we were curating the descriptions from attack framework, a lot of the descriptions had overlaps, and they were describing multiple tactics. Like here, this figure A shows the actual overlaps, payrolls overlaps between MITRE tactics. And sorry, I went to the next slide. So this shows the actual overlap of the tactics. And what we tried to do is, after supervised training, we wanted to see the overlaps between this secure BERT model that we had and also GPT 3.5 turbo version. And as you can see, the GPT 3.5 tends to kind of predicting multiple tactics for each description. So this shows that there in the descriptions there are ambiguity, and that we kind of need to understand how to deal with that. And as we gave it the classifier, it tend to really, because it has seen the data before, most of the data before, so it performed very well on the attack descriptions. And here shows the results too for that. The accuracy like 92%, and for GPT 3.5 it was 44. However, what we wanted to, in order to confirm the results and also see how it performs on like other data, other cyber attack descriptions, we went to the APAC framework, and we find those descriptions that deemed relevant to attack taxonomy. And we curated around 180 descriptions, which figure A here shows the actual overlap between the tactics. And when we gave it the classifier, like the base LLM and also the GPT 3.5, we saw that both of them are performing very bad on these descriptions. And here, like the accuracy was like 30% here. And as you can see, like for KPAC descriptions, the base LLM, because it has seen the data of attack descriptions, it tends to differentiate between the tactics more. However, the GPT 3.5 still tries to kind of process the descriptions, but put more like tactics in as its prediction. So what we saw is that as kind of overall conclusion is there in the descriptions there could be ambiguity, and it could be interpreted differently, as GPT 3.5 showed that it cannot specifically predict the exact tactics that it was mapped in the attack framework. And it shows us that we need to do some additional steps, future steps, like whether fine-tuning it can help for them to better understand for these models, or even whether should we have explainability in all this process to see why the models made such a decision. And try to keep it short. And thank you. And that was the research I've been doing. Thanks.
Yeah, go ahead, Pradumna.
So I'm going to present the very general idea of like what Stephen already mentioned about using zero effort for attacks, but more in a code intelligence aspect. So I'm going to talk about source code summarization. So I see like there are a lot of like language model that does the same thing about source code summarization. So it analyzes the code and it generate like comprehensive documentation or like just summary of like what the code does. So a person who doesn't have like much idea of how to execute and code, or if there is already a command or function level of code or scripts or series of commands, and he wants to understand that what these commands are. So we can use like large language models, and then we can have a source code summarization. So for example, there are a series of very, very big codes, and understanding them requires a source code summarization. So there's a lot of work already been out there which deals with the software engineering aspect, but not in cybersecurity. So I'm working on the software engineering in cybersecurity engineering side, in which we can actually find you the pre-existing models or with the cybersecurity scripts, codes, and commands and logs, and then try to generate like summaries out of it, like what this function does, what the scripts do, what are the series of commands are trying to convey. And we can do that in extractive or abstractive summarizer, and maybe a combination of both of them. So this is a source code summarization. And the next could be code generation, which is also known as like NLP code. So given a cryptic description, like basically a prompt, and then to generate a malicious code or a function level scripts about that. So using a natural language and the cryptic language, we can actually fit in the model, and then model will try to generate a particular code scripts or commands or logs for that particular attack. So for code generation as well, we have a lot of pre-trained language models, which are Codex, CodeGen, CodeGen X, and also like GPT. So using that, we can actually generate a function level of code, and then we can try to execute the adversarial attacks by providing this natural language. So this is one of the example which I use, CodeGX, but obviously this model was not fine-tuned or trained with a lot of cybersecurity codes. So that's why it was not able to predict actual code, which is SQL injection attack. So my question is about how we can use this. So basically, this whole process of code summarization and code generation is basically weaponizing NLP for automating cyber attacks. So while this like possibility is not far from becoming a reality, it is like very crucial to explore like how we can actually prevent and mitigate such risks. So like I want to go in depth, like how we can actually like as Steven already show, like we can use that thing like in the defense part as well. So how we can actually prevent from happening these things, like how we can actually do that, and so how we can effectively stop and prevent like the weaponization of NLP for cyber attacks. So we have to like develop a robust defense mechanism that can detect and counteract the malicious use of NLP techniques to cybersecurity. Other than that, like there's another research questions, which is the attacks on the machine learning models. So basically, it's basically introducing perturbations in words or character level or sentence level of descriptions, and that would lead a machine learning model to misclassify the data. So for example, there are a lot of state-of-the-art models already out there who are like working 24/7 and trying to detect what kind of vulnerability it is, and kind of defining and classifying various attacks of logs and alerts, and even like minor attack TTP. So if we have a particular model that like Reza already told, so if he has already developed a model which actually can classify all the TTPs, extract TTPs out of a documentation or a code. So how we can actually mitigate these kind of attacks by introducing a perturbation in the word level or character level of this descriptions, natural language description, it will actually lead to data misclassification. So how we can actually mitigate these kind of attacks. So those are like the general level of all these kind of questions that are open for like researchers, and how we can actually build a comprehensive defense mechanism for all of this automation of NLP for cyber attacks. Thank you.
Great, thank you.
Very
So-
good. Thank you very much. Those were great presentations. Go ahead, Jay.
No, I just want to invite the audience or anyone who want to ask questions. I think that'll be good.
You can just speak up or raise your hand, whatever you're more comfortable with.
If I have a lot of questions, so I'm going to start just to get people starting off things. Steve, so of course the question is first for you. So I trust you, but I also don't trust you, right? Because I feel that in our experience using the GPT APIs, it doesn't give us that clear of indications, and I know there are also guardrails. How did you make it work, right?
Yeah, so a lot of it is don't use the web interface. The web interface has a system prompt that you have no control over it. As for how to make it work, it comes down to that kind of prompt magic of really in understanding that, or the way that I've been looking at it is that if you have 10 humans, how do you get the 10 humans with a prompt to give you the exact same response every single time? And now I think that these LLMs is just another programming language. And so it's focusing more on commands on the LLM, more so than asking questions or eliciting knowledge from it. So I find it very good at reasoning on, given this context, what should you do? And you do have to be very precise on the types of prompts that you give it. But I can assure you, this works, and it's pretty crazy. But I can't with the interest of time, I can't give our paper that's in release review now has in-depth detail of exactly the prompts and how the prompts were designed and used to then give consistent executable output. The hard part is getting this LLM to give you consistent, not garbage, to start telling you what to do. But and then I should also mention GPT-4 is even better at doing this. So it's yeah.
So as a related question, Steve,
Yep.
What's your sense of the barrier to entry for a random attacker out on the internet to basically take this ChatGPT technology and integrate it into their tools?
It's at least on the defensive side, it's a lot easier. It does have quite a good understanding of reading an alert, kind of understanding what the context of the alert means, and then give kind of the countermeasures. As for attacks, it's still pretty brittle. And I should mention that I'm only doing remote-based Metasploit attacks, which are very easy anyways. It is something you can Google, but we now have the capability of adding in plugins that can then reach out to external knowledge sources, reach out to external tools, and that's where it's going to start getting a little, I would say, spooky. Once it's starting, once we start to give it more advanced, state actor tools, it'll get better. But no, there's still a lot of engineering required, like the prompt chain. You can't just ask this thing, give it all the information, and then one shot give me your executable. You do have to break it down, but you also have to think about like for example, if I give you a programming task, you might not immediately go straight to writing the code. You might go to an intermediate step of, first I have to draw a UML diagram to give me a format that's starting to make sense. And then you can take that diagram and move it on to the actual code that you're looking for. You have to kind of do that same sort of thought process with this at the moment. But now as the new GPT models start embedding chain of thought into its model, into its decision process, it starts to get a little more crazy.
So it sounds like it's not something that an attack developer could turn into a tool that they could then sell to people who don't know how to use any of the tools yet. But it sounds like it's moving that direction quickly.
Yeah, it's not there yet. In terms of that true one click, zero effort. I should mention, it does take a couple tries of reasoning to start, then all of a sudden, boom, nailed it. Depending on the Nmap scan. So again, Metasploitable really easy, but now we're moving on to harder capture the flag kind of scenarios where it's not remote accessible. It's because somebody left a password exposed on a website, or there's more of that reasoning, and that's where it's going to start requiring a little more engineering to do.
Yep, thank you.
I think Matthew has his hand raised.
Good to see you all. And it's been a while since I've been here, so it was really cool to come back in and see such great talk. I did miss about the first 15 minutes or so, so I'm sorry if you covered this. But I'm wondering, and this goes for all the speakers. If we go and look at MITRE, we've got classification systems and things like that. I didn't see an ontology around something like the common attack patterns and things like that. classification systems. And I'm wondering if there's a role here for reining in, you're looking for, the same answer 10 times from 10 different humans kind of thing. Is there a role here for appropriating the logic of ontological models to rein in some of the sort of hallucinations or different answers that may be happening from the LLMs in order to get something that you're more sure of? Or am I just out in right field?
So what we've been doing is, now we're trying to go away from the LLM's knowledge and then reaching out to a ground truth, like known source of information. So like Bard, the Google's LLM can reach out and use Google search and then bring in some factual knowledge that we know it can be used, and then the LLM can reason upon that new factual information. And so that's where we now need to start going towards, instead of just relying on what's contained specifically in there.
Yeah. Basically,
I have some comment. I think I agree with Steve on that portion. But the other element you asked about the ontology, right? The KPAC or attack framework. Certainly that over the history of past 20 years, from a long time ago today, we as professionals in this operation still are figuring out how to categorize. I'm using the word categorize to be more generic about this different, whether it's kill chain or attack techniques, tactics. One of the things that Reza found out, and we really agree, is that our writings are not great and our interpretation are very ambiguous among them. And I'll give you an example. We didn't report this in the paper, but essentially that if I were to ask GPT to rewrite a particular techniques or tactics or KPAC description, it writes a lot better than whatever is on the website today. So that's different kind of things that Steve was talking about. Generating attack campaign is more about interpretation and generative AI side of things, whether you generate well. So I don't know whether ontology helps or hurts. So that's kind of the comment.
Well, this is kind of my thing. It's not just about the classification systems, right? But it's about how the vulnerabilities relate to the attack patterns. It's about the relationships between these things that aren't necessarily hierarchical, and it's how to building out those logical relationships such that you can reason over those to kind of make sense of. That's kind of where I was going. And I don't know if that kind of ontology has been built in this space or.
At least here we have a tool called that my coworker Eric Henberg, who also worked on this, it's called Braun, and that use BERT to then take in all of this MITRE, KPAC, countermeasures, everything, and then tries to link them together. And that's what we use also as our kind of knowledge source, is, to verify how does a KPAC relate to a specific CVE. That chain might not exist directly in MITRE, but he has built out the ability to, look at relationships across many types of cyber knowledge sources.
And you're storing that in RDBMS or something, or how is that? What does that knowledge base look like?
That's area. Yeah, I don't know much about that one, but we do have a paper. I can share it to Dr. Yang. And that's a pretty dense paper.
Yeah, that paper would be great to have.
Yeah.
I mean, does he have a GitHub or give?
Yeah, it's all open source and you can use it today.
Excellent.
Thank you.
Go ahead, Reza.
I do have a question for Steve. Like you use like GPT 3.5 API, and so GPT is a very large language model, around 160 billion parameters, but it has a lot of general knowledge unrelated to cybersecurity. Have you tried like using a smaller model with, I don't know, 30 billion parameters, but just specifically trained or even fine tuning it with cybersecurity to see how your research?
I would argue that some of that general knowledge is very useful. I mean, I don't have any sort of feeling, or data to back that up. But I think that general knowledge is very good at doing the language understanding and then performing tasks that aren't cyber related, like the translation and all that. So I think that yes, we could go into a more security focused version. But also like the capabilities of GPT-4 has more security than GPT 3.5. And that's just getting better. And so, no, I'm not going to go into fine tuning or anything. I would say it's already really capable. And we'll see what Microsoft does with Security Copilot and all that stuff. Like
And I think it's a race to the finish with all this LLM stuff, and it will never finish. So now that it's escaped, I worked on the Watson strategy and AI and deep learning and deep QA and all the other things they called this stuff years ago when people said it'll never break out of the lab. And here we are. So I think it's going to keep going. I'm sensitive that it's the top of the hour. I can go for a few more minutes. So if any of you have to leave, thank you for joining us. But let's continue with the Q&A if we can. Shashank, do you have a question?
I think Pradumna raised the hand first.
Oh, I didn't see the hand up. I'm sorry.
I just have one question. So, Steve, in your PPT, I saw like there's a defense mechanism you're talking about how to tackle these LLMs and the prompt engineering you told about. So, can you briefly describe what could be a defense mechanism, a robust defense mechanism that can mitigate or prevent these kind of automation of attacks from like zero effort attacks?
Yeah, so like I didn't have it in this presentation, but I have like a couple examples of if you're a penetration tester, maybe you'll go through some sort of enumeration tool for your MySQL server, that will try to penetration, or try to test your server whether or not certain things are exposed, whatever. And that gives a very lengthy, kind of hard to interpret report. And so if we can, I call it SOC GPT. But we can feed that into GPT, give it some sort of context of the machine that you have, and then it can give countermeasures of, oh, this hash is outdated, or this uses an old version of SHA hashing that's insecure. You need to secure that. Oh, you have a default password here. So that can help the SOC understand, instead of trying to read every single line of a lengthy penetration test report. Okay, now it can start interpreting that, help you give guidance, or what later on we can then prompt it, give it that recommendation, and then give me the code or countermeasure that will close that vulnerability.
Shashank?
Right. Hi, Stephen. Firstly, excellent presentation. It's really interesting. So I like to ask you, since you were talking about GPT-4 and prompt engineering, I'd like to know the involvement of short-term and long-term context awareness for the large language model, which I think is really important. As in short-term, having knowledge about the specific part of the attack chain that is ongoing, and long-term includes general information discovered throughout the cyber process that's been going on, all about the vulnerabilities and the process and all. How good is GPT-4, and do you think we need to externally handle short-term and long-term context awareness?
So what at least for short term, what we're limited by is context window. So like GPT 3.5 is 4,000 or so tokens. And so we have to encode the history of your cyber attack within that window, and then also allow for some sort of response. And then so at least GPT-4, at least my API token increases that to 8K tokens. And so this allows us to give us much more context of what commands that we ran prior, what was the outcome. And now we're getting to the point of, yes, that information is getting way too long to fit in even an 8,000 token limit, and it's also getting pretty costly. So we can store that information, store it into an embedding, and then retrieve that information when we need to. As for long-term, that's dictated by either the information within the model itself or some sort of truth database that we have, whether it's a Google search or whether or not it's our Braun database, cyber database or something like that. So I don't know if that answered your question, but
Yeah, that did. Thank you so much. I also have another question. So, as per prompt engineering, I agree about what you talked earlier about GPT having the general knowledge. The reason why we shouldn't really fine tune it, that really cuts it off to that. So, as for your prompt engineering, are you currently doing prompt engineering? Some of the tasks that would involve would be to really prioritize the tasks, as in to handle and prioritize what kind of, for example, on the vulnerable ports and on services discovered, which one to prioritize first. And then can one prompt really handle the entire attack chain? Would you rather use multi-agents and to use a different prompt for all of them? So more on that.
So first, definitely use different or multiple prompts to do multiple tasks. Doing all at once is quite a bit tougher. And then it starts to go kind of off the rails if you give it way too much information. And I'm sorry, what was your first question? The first part of that question?
I wanted to know how you would prioritize and focus on, because as my understanding, there's a huge graph of many various, which vulnerability would you prioritize to focus on, and then couldn't one agent really handle the output of that one, go back and do the scripting for that?
Yeah, so that was actually kind of a big problem initially, is that the Nmap scan would give you at least for Metasploitable 10 different services to prioritize, or not to prioritize, that it could possibly look at. And at this demonstration, we let the model prioritize. We don't give it, we want it to exploit, so it's up to its task. So what we found is that it picks the lowest hanging fruit, which is in this case that VSFPD vulnerability that would never actually exist in the real world. It's kind of old, and it pops a root shell immediately. So if it sees that, it goes for it. And so we went through kind of a study of, well, what if you remove that? And so it definitely just prioritizes whatever is easiest, I feel. But I should also mention now we're at a different level of planning that can then we can prompt it to better prioritize things.
Great. Is there any other question? If not, then I would like to make a quick comment and then also plug in something for what Steve and I are currently doing. So one thing I think that Steve presented something very interesting, very scary, but also very interesting. There are some limitations, as Steve pointed out, and Reza and Pradumna probably got a feel as well, because based on their own experiences. So one thing that I want to mention is, so this past spring, I had a undergraduate student working with me, and he is more like a student hacker. And he went through a lot of things to show me how his thinking thought process. This is not a formal research study. So a lot of times, every single step I ask, why did you do that? Why were you looking at that logo? Why were you looking at these particular signals on the web page that he was doing to hack? And a lot of times, by experience, because I think that that's what is kind of vulnerable. Like, give me some information. So what Steve demonstrated right now, of course, is not connected. Okay, here is the image on the website that looks like. So there are things like that, maybe a lot more difficult today, but as Steve said, GPT 4.0 may be linking to even more things, and BART is connecting to the Google. So I'm pretty sure someone out there is working on some of these things. I'm pretty sure this year's Black Hat and those conferences, DEF CON, will have some demos here and there. I think a year from now will be very different stage. So it's also very exciting for the research community and practice communities, exciting both ways, good way, bad ways, for what this means. So one of the things that I want to do a plugin for Steve and I, we are working with a few other people. on a kind of a roundtable piece we'll see whether it will be published soon or not, about artifacts. So one of the things that we've been asking today, talking about a lot today, is the prompts. So like Stevie, his last slide, really like it. The software engineering 4.0 is how to translate our thinking into prompts, right? And that is interesting. So how do we consider prompts an artifact in research publications? So those are the things that we'll be thinking about and try to provide our comments, hopefully in the upcoming pieces in the next few months. All right, thank you, Florence, Chris. Thank you again for hosting us and also give us extra time for this. Thank you very much.
Absolutely. This was great. So all y'all keep going because there's a lot going on and the bad folks are trying to race ahead of you, or like tunnel underneath you or whatever. So this is going to keep going. Cybersecurity is just going to become more intense. And then when we have holograms and I don't know, I'm just saying, there's going to be more going on in the future. So the more that we can do, the better. And we're really happy that you're helping lead the charge. So thank you for all your great work. And Jay, thank you as always. So everyone be well, be safe. Hope you can breathe well over the weekend. The air is getting clearer up here in the Northeast. I pray that the fires end in Canada. And now you know what it feels like to live in California if you haven't been there for the fires before. So everyone stay safe and thanks for all